In the name of God, the compassionate, the merciful. This is the Friday session of the week 3 of our practice sessions for C++ template metaprogramming. At the beginning of the session, we had a reminder regarding the pack expansion table. So what you are seeing here at the moment is that cheat sheet for the pack expansions. You have already received a copy of this in the first 4 chapters of the book. Now, last week we went through take and filter, and so this week, sorry, not last week, last session. This session, we are going to go through splitAt and span, both of which require more than one implementation. So I hope that we can finish them. Now, so there was a question from Niels that I needed to answer. Niels, please.
Yeah, I'm trying to use requires for the filter function that we did last session. But I get an error where it says expected semicolon at the end of declaration.
Right. Let me play. What's happening? Why is this guy frozen? Right. Would you be interested in taking a look at this, or is it that you would want to show me your code?
I can just see if I can get it to work with your.
Don't try to copy what is here. Just try to spot the difference if you may. Otherwise, I would try to help you with your own code, because I want you to be able to recover from such mistakes the next time they happen. Okay.
Yeah, well, I'm doing something similar to what you have, like size of on the take. I guess I'm just doing it wrong.
Okay, then so I guess you mean that you have your second overload has an x's only, and then it checks for x's to have size greater than 0. Is that what you say?
No,
you know what? Just show us your code. I think that's better. Okay. Let me try to. Where is that? Oh, where's the sharing? Right. Okay. Okay. Now you can share, and I'm trying to see whether I can switch between your share and mine, so that I don't. Nah, I can't. Okay, then I have to stop sharing. Okay, now I can see your code.
Yeah.
Okay, well, so do you understand? I mean, I thought that you had 2 overloads, but you don't.
No, this is just because because I remember my last function wasn't correct, or it didn't work. Is it because it doesn't work and that's why it just gives this error, or is it because I'm using this requires?
No, I don't think that that's the reason. I think so. Here's what is happening. First of all, you require that the tail, you are requiring that the tail is non-empty.
Yeah.
Okay. And you're requiring that your list has a head in addition to the non-empty tail.
And yeah, okay. So
which
I will
means
end
that
up
you're requiring that your list
have at
should
least two
be
elements.
of size 2.
Yeah.
Okay. But then you perform recursion, which goes below that, and you don't have a recipe for below that.
Yeah.
Okay. So here are a few things that you probably want to do. You might want to, like I did, you might want to have 2 overloads. And then check. So the first one would be when you have an empty list, which doesn't need to be templatized by X and X's and all that. And then you would have another overload, which does the computation for when you have a non-empty list. And with the current engineering of the non-emptiness at lines on lines 51 and 52, you do not need to put that require statement on line 53.
Yeah, when I okay.
Because that already, the previous 2 lines do already handle the non-emptiness.
Yeah.
Okay. So that's that. Now, I think the error message that you used to receive, and this is my first, no, a type specifier is required for all declarations. Right. I don't think this is related, but let's see what happens when you remove that.
Okay. Yeah, no.
Right. That one is different.
Will it compile though?
Okay.
So they had C++.
Oh.
Yeah.
Is that 23 or 28? Right.
It says 20.
33.
Yeah.
It's 20. Okay. The error message says 20, but that's fine. Apparently your version of C Lion doesn't understand 23. But that's fine. So that's just a warning. It's not an error message. Right. You see, can you do something here? Can you just on line 51 remove that leading type name F, and then the F which just got read, you just put auto over there. Okay, good. Right, now let's see what it's unhappy about. I think I know what's going on. Let me just skim through the error messages. Oh, what does it want? List for list. Well, it looks like the problem is with your function PP. Wait. So is that your post-pend?
Yeah.
Okay. Now try to do this one instead, and we'll then leave your presentation of the error messages for after the session, if it's still preserved. Can you do a prepending of x to the filter?
So okay.
No dot. No. What are you doing? Oh.
Did you mean like this?
No.
Okay.
Remove the highlighted part. Then replace that PP with prepend. Do you have a prepend?
No, I don't have a prepend.
Ah, okay. Well, I think actually your anyway. So the problem is in the implementation of PP.
Okay.
For post-pend, right? Now let's leave that to after the session.
Yeah.
I don't think that this is a problem with
the filter.
No, it's not. I don't think so. But I'll give it a go after the session. Right. Let's see. So let me now share back. Okay. Right. So yeah, we did go through filter, and so the idea was that this session we are supposed to go through splitAt. So let me bring up the splitAt implementation of. Right. This is the splitAt implementation of Idris. And so the idea is that you when you perform a splitAt location n or position n of a list of n plus m elements, you get a pair of vectors, a vector of n plus m elements. You get a pair of vectors which do the well, the first one is the first n elements of the vector, and the second one is the last m elements of the vector. And now I have to say I don't know how to read this. My address is not enough for understanding what is going on.
A width lets you split, like basically add a new variable to splitAt. Meaning splitAt is confusing, but like a new I guess parameter to k-split on in the context.
Okay.
So they k-split on XS. And the stuff on the left is stuff that's already assumed. Then on the right, you get a pair. So you get the returns of splitAt XS K M XS. TK would be
I see.
Vect M, I think.
I see.
Yeah.
So this is like, let's say that we are already done with this part. Then let's do this one as well. Is that what you're saying?
Yeah, it's like, okay, when I split at this, let me also split at that part.
Okay, at K, and then?
So, and then
given that the result is TK and DR, then I would like to, okay. Thank you very much for teaching that to me.
I used it in my master.
What this? So the same notation is available in Agda?
It's from Epigram actually, which is McBride's.
I see. Okay. Very good. So I'll leave it to Jan to explain to you this implementation. Please. Oh, you just wanted to have a spoon.
No, okay.
Okay.
So you add the extra split at K, since this is the SK case, and you get the result. The result is a pair. The pair has to then be,
and the pair is shown here, right? So let's say that you got the pair here.
So let's see, let me think about this. How large should TK? I think TK should be TK should have K in it, I think, or like K-1 elements, and then DR has the inductive call, I think.
Right.
With the rest of the elements.
Yeah. So DR is the kind of the remainder.
Yes.
Right. The remainder. Yeah.
So delta R, I guess.
Yeah. So so you see, maybe I should share this one with this other implementation of it with you. Consider so my apologies. Jan, were you done with your explanation?
I could try again if you like.
No. Were you done? Were you? I interrupted you, and I should have not done that.
It's fine. It's fine.
Okay. So now maybe I should show you something else, because I think that this doesn't quite read well, or at least is not very
helpful. Not quite sure how to translate that.
It's sort of like the recursion instead goes on the right, like on the rightmost term.
Yeah, let me show you something else. I'm gonna Oh, you know what? Can I just ask everyone to open that file that I just shared with you, the link of to the Estonian University, and then find the implementation of splitAt over there, whilst I'm trying to find it also. Yeah, sure. The easiest way is for me to just
That's kind of straightforward.
Yes. Yeah.
More streamlined.
Yeah. So it's that easy, and I don't know what made Idris to want to do it in just one go, but instead of delegating the job to take and drop. So with that in mind, so you see that it's a pair of the first n elements and the drop of the first n elements, right? Now so that means that if you want to implement that, you would need to have take first implemented, and then drop first secondly implemented, and then you return a pair of the results, right? Now I am going to go to take now of Idris. This is something that we did in the in the previous session. So does everyone have take?
Yeah.
Okay. Now drop is relatively similar. Let me go to drop. Right. Okay, here is drop. So you have 4 minutes to implement drop in C++ TMP. One minute passed. Two minutes passed. Oh, by the way, I realized that, well, I watched the recording and I realized that my whistling, I whistled for you this, The Last of the Mohicans, and it was filtered out.
I heard it.
You did? Okay, well, but it was not in the recording.
It might have been copyrighted.
Well, if that would have been the case, then YouTube should have told me about it.
But did everything get muted? It might have been on Zoom's end.
No. The part that I was saying that part was there, but the whistling was not. So you know, that's interesting. I think that's the noise cancellation only.
Could be.
But the strange thing is that it was. What was it? Sorry.
No, I watched the recording because it kind of cuts in and out, so I believe it was the noise cancellation.
Right. Yeah. Okay.
Mind if I make myself a coffee?
Not at all. Go on.
Fantastic.
Otherwise, it's a bit very well done if the YouTube.
Okay.
Copyright.
True.
Right. Guys, do you hear the page bell?
Was there a page bell?
No, you don't hear it. Oh, really? Okay.
So sorry.
A tiny bit.
Disappointing.
You hear it a tiny bit.
Hearing.
Okay, well.
Yeah.
Anyway, time's up. I'm sorry that the page bell doesn't work, but time's up. Is there anyone who has done it? You have. Okay. You have also. I'm very proud of you guys. Thank you very much. Daniel, you are the easiest target now because you were not here last week. So I'm gonna stop sharing and then you start your sharing.
I thought I would test it first at least, but all right.
You will do that in front of the public.
Oh, goodness. Do you see it?
Yes, we do.
Yep.
Okay. So you have just one. Okay. Right. So n is less than the size of x is. Cool. And if n is right, drop.
Or we just
Well,
request to go forward.
Yeah, okay, okay. That's good. Yeah, that should do.
File 3. That looks about correct.
You're dropping one of them, and then you get.
Yeah, if I drop this, that's empty set and more. Just errors.
Right, can you drop one of them? Let's see. So your L3 is that? Yes, good. That's great.
Okay. -1. Yeah, that's not.
Right.
I did have one question.
Right. Yeah.
But it's regarding take. So if you want to comment about this, you can do that first.
No, I just wanted to see whether you're using a size T for the N. And
Yeah.
you are. Did you introduce that to be of the namespace stood? Because I think from C++20 they decided that this has to be in the namespace stood.
No,
STD.
I haven't introduced.
That's fine. A lot of the compilers are lenient on that, but if you want your code to be portable
compliant.
to portable to other compilers, then you have to put that stood stood at the front. Yes.
Right.
Now, let's hear your question. Well, sorry. Before anything else, guys, is there any question on this implementation? No. Mikhail, are you following?
Yeah, I'll just
maybe it is.
Yeah, very good. Now, what was the question on take that you had?
I'll just see what happens.
Sure.
Yeah, it's here you go. Because I just pretty much took take and swapped it around. I was wondering what was the difference, because I guess I'm a bit I need a bit, some more clarification between packs and list, since
okay, I see.
In some implementations you prefer to have, as the parameter L of the list and then take the head.
Right.
And then in other cases you have X and X's, and then you prepend X. So instead of the head of L.
Right. Well, some of the times, not all of the times, but some of the times that's just a matter of preference, as you just put it. But sometimes there are subtleties involved.
Okay, could you clarify a little bit what the actual difference is? Because I think this as well.
Right. Well, the usually when we have to go for the way that you so you had two implementations, I think right.
This is
usually when you right. So usually when you have to go for take one or take on line 84, right? Usually it's because in the overload resolution, you end up having the wrong overload if you do it in the fashion of line 92.
Right. Second implementation.
Or the other way around. So it's a matter of making sure that the overload resolution doesn't get confused.
Right.
Now, I can't recall the cases in which we did that, but I think take was one of them. Let me just go to my implementation of take, and I can verify that.
Yeah. No, because I was going through the recording, and when I should have told you that if But I wasn't there in the lecture, so I mean that's why I'm asking now afterwards. So that's my bad.
Ah, so you didn't finish the lecture?
No, I did, but I wasn't present when you're going to take, so I couldn't ask
But
this
I
at the
I
time.
should have explained it in the recording as well, right?
Maybe not this distinction.
Okay.
Not that I recall, at least.
Right. But anyway, the thing is that when you have to, so there are occasions when you have to do that. Most of the time, it's not just that I have to. It's a matter of preference. So it's whether I really like to take the head and then do something with it, or I prefer to have the eggs ready. It's just a matter of preference. But some of the times that's enforced. Now I'm trying to find an occasion when that is. Let me see. Yeah, maybe we should take this offline because I can't recall any occasion off the top of my head when we had to. Yeah. Okay. Now, let's see. Let me show you my drop and see whether there is any differences. No, not you, not you. Okay. You can see my drop now. So in my drop, I have two overloads, the one for the empty, and then the one for otherwise. And like you see, this already means that n is non-zero. No, x is non-zero when we check for n equal to 0, right? Which means that when we come to this line, tail of L makes sense, right? So that's pretty much the same as what I did with take. Right?
Yeah.
Okay. Good. Now, so we now have take and drop. Now it's time to go for splitAt. Now I'm going to give you a clue, and I'm not going to make it easy for you because you are expected to grow the. Is it that one? No, it's not. Let's see. So many pages. So, it's this one. Yes. So there is a header called tuple that you will now go to, like I am going to, on CPP reference. And you will read through this a bit. Specifically, you would need to go to make tuple and the constructor. So you should read these parts and this part, make tuple. Or you actually click on make tuple and you read through the explanation. You don't need to read through in the return value or the possible implementations, but the examples are instructive. Then you will be ready to go through the implementation of splitAt. You have, let's say you have 5 minutes to go through tuple and make tuple. 2 minutes past. By the way, if you're done with reading those 2 pages on CPP reference, and you would like to go on with the implementation, by all means do. The implementation is almost straightforward if you understand these 2. Three minutes past.
Feels like a game show when you read out the times.
Well, I'm glad you have that. I'm glad you have that feeling, because it is a show after all that we hear on.
We need the countdown in the background.
I don't know how to do that.
I don't.
Just go on.
We can work it out together.
That would be very much appreciated. Yeah, that would be very much appreciated. I mean, anything that
countdown
makes
music.
This, anything that makes this even more fun, then I'm game. Go for it. Yeah. Okay, I'm gonna pour my other tea and come back.
I'll be right back. Hot water wasn't ready. So let's see. You should be done with the implementation also by this point. And I didn't tell you to go for the implementation, but is there anyone who's done with the implementation? Very good, very good, very good. Niels, your turn. Show us your implementation, please.
Share screen.
Okay, that's excellent. Yes, as easy as that. Excellent. Thank you very much.
Yeah.
Does well, what don't unshare. Does everyone understand this piece of code? His lines 81 to 85. Okay. Now, Niels, I would like to draw your attention to the signature of splitAt that I showed you from Idris.
Yeah.
Now, I would like to now see whether I can. I'm gonna try to share. I'm not sure whether you can see that.
I think I have to stop share.
I can share a link of
Right, can you guys switch between the two shares? I was told that you can do that, but I don't know how to do so myself.
If you press view options, you can switch between the two screens.
View options.
Yeah.
Daniel, right. Okay, Daniel also sent the link to. Okay, thank you very much. Now, let's see. Let's go to splitAt.
Oh, I see what you mean. On the top right, it says view, and you can click on it.
I see. Okay. Right. Okay. So splitAt, you see, Niels, what it does is that it says explicitly that you need to have n plus m elements here, and n elements here, m elements here. Right. Now, we discussed why we will not be able to enforce this part with the current engineering of our lists. Right.
Yeah.
But we also discussed that it is possible for us to enforce this part. Now, how do you do that?
I don't know how to do it exactly, but I remember we know that we know the size of the pack.
You know the size of the pack. Yes, that is true. That is true.
Yeah.
Okay. How do
and since we know we're taking n elements from the pack, we can do subtraction and addition to find out.
Okay. Let me let me maybe show my solution, and probably we can discuss details of that. But anyway, your implementation was good enough. Okay. For now. But when you hand over your implementations as the project, and you're expected to do slightly better. Let me share these guys and get to right. Right. The only thing that I have here is that n is less than the size of, or the size of the pack. Right? Which is, it's not exactly this, because well, in here you are using this m thing on the right hand side of the final arrow as well. But so long as you don't want to do that, it's a very good kind of simulation of this condition. So when you perform this check that requires here, you are essentially telling the compiler there must be an m for which size of the pack is n plus m, right? But you don't use that extra m, because you can't do that here, you know. So James, you look confused. What is confusing you?
I'm seeing if I can massage it into being a bit stronger typed.
Oh, I see.
But it's not doing what I want.
Right. You know that the trouble with using require statements, as I explained it in the previous recording, is this. You know, requires is a an instruction for the compiler for doing the right overload resolution, right?
Yeah.
So that means that at the point where the compiler looks at these require statements, it's already done with the typing and with the type signatures, which means that you can't enforce anything on the return type.
That's exactly the...
So, yeah. You know,
okay.
like I was trying to explain that in the previous session, you know, the type theory that is being used here in Idris is actually superior to the type theory that we have in Variadix. Now, I haven't done this myself, but I'm positive this is possible if we wanted to have an implementation of vect in C++ TMP, which explicitly carries around its size, then this might have been possible, right? But like I said, the point of this module is not that you can. It's not that you kind of champion other languages. The point is that you learn to use C++ TMP in the way it is used in reality, right? So, okay, thank you very much, everyone. Now,
I have a quick question.
Tell me.
This is a throwaway question. I was just wondering does it make any difference if we used make pair instead of make tuple?
Oh, well, no, but that would have been so let me go.
Because on the first very start of the tuple page, it does.
Right.
I've been told that pair is higher performance.
Yeah. Is a generalized pair, and pair is a special case for two objects.
Yes, indeed so. Indeed so. Well, but it's a part of that is a matter of preference, but regarding the performance, well, if your performance means compile time, and you are worried about your compile time, then yes, you should be using pair. But if performance means runtime, then no, there is absolutely no difference, because everything that we're doing here is compile time.
Right? How about grading of our assignment?
That's absolutely fine. You can use you can use the right things.
I was more concerned about that, I'll be honest, but thank you.
No,
you lose marks for that.
You'll collect you know, good marks for both. Don't worry. Yeah. I mean, if I you know, I'm sorry that I haven't still sent you the statement, but you know where we're going with this. You kind of know your assignment. But anyway, so my general policy about marking is that if your code has the minimum requirements, then you get a pass, no problem. If you have done things more than that, you get bonus marks, and I'm very glad to see things that I would go for bonus marks, but it's that's just optional. You know.
Yeah. Okay.
Yeah. Now, I think the next thing that we have to go through is span. And span is one of the strange things in. So yes, it is span. So interestingly enough, let me go to the where is that? Oh, come on. So span is just a pair of take whilst and drop whilst. Now, when I tried to find that in vector, and I think there wasn't any. Yes, so you see that there is none in vector. But let me see whether there is any. Oh, there is one for lists, but there is none for vectors, and I don't know why that should be. Anyway, is everyone familiar with takeWhile and take? No, there isn't any. Okay, let me.
Yeah.
Let me show takeWhile of
Sorry, what does span do?
Right, I should first explain to you what takeWhile and dropWhile do.
Okay.
So this is dropWhile in Haskell, right? The difference between drop and dropWhile is that dropWhile receives a predicate, and it keeps dropping once the predicate is correct, right?
Okay.
And now take whilst this is the opposite. So it accepts a predicate and it keeps elements so long as the predicate holds, right? Now so let's go step by step. You have 4 minutes to implement takeWhile, and I'll be back when I'm done with pouring my tea. 1 minute left.
Does it take like until the end of the list, or until it meets when a predicate is false?
Sorry, I'm not sure I understood you.
Does it continue until it's at the end of the list, or does it continue until it meets false?
Well, your response is already on the screen. Can you not see my share? So you see these two cases? This is one of the, and this is the other.
Okay, yeah.
Okay, time's up. Hopefully you heard something of this. Okay, who's done? Ah, good boys.
Almost.
A little bit.
Okay. I've done it a bit differently. I'm having a play.
Very good. Then impress us, please.
Not quite yet. I just need to
not quite yet.
The last bit.
Okay. Okay, well then Jan, you haven't shown us your implementations thus far. So I'm gonna on share. Are you're not still done? Yeah.
I got some errors.
Oh, I see. Okay. Okay, I'll give you some extra 30 seconds just to put pressure on you.
Okay, now it works. Okay, at least it compiles.
Very good.
Where's the share? Please. Why won't it let me share?
Really?
Sorry about this. I believe it's gonna be.
That's okay.
Yeah, there we go.
Ooh, your coloration is now totally different.
Yes, I changed it. So this one. I think I might have gotten the ands wrong or not wrong.
Let's first go to your implementation logic.
130.
Oh, okay. I misunderstood it. Okay.
Well, is there any reason why you are putting
I think I could just call on the whole list there actually.
Wait a moment.
I think I need to prepend.
Wait. I something just grabbed my attention. On line 118, you are putting your then branch in a pair of curly braces, and
yes. And did I break it?
No, that's completely fine. I just it stroked me. It stroked me first because I thought that you were doing something more general. I thought that you were returning a lambda, and I thought, why would he want to return a lambda?
Well, I just love lambdas.
Who doesn't?
Oh, yeah, exactly.
Okay.
So
no
lambdas. So 118. I checked.
Well, your first of all, your I'm afraid your logic is wrong.
Ah, good, great.
takeWhile doesn't need a doesn't take an n. It takes a predicate.
Okay. Yeah, I wanted to make it so that I guess it doesn't take an n at all. Yeah, no, you're right.
No. Okay. So that one's out.
Let's get those out.
Right. Okay, that's much better. So you take a list of, well, and then, so where is your case for when take becomes, sorry, you hit an empty list?
Oh, I don't have that.
Okay.
I thought the variadic would handle it, but no, I'll make one.
Yeah, let's okay, but the rest of your code is good.
Good.
No, you just made a mistake. Distinguish between a type and an instance of a type. On that exact same spot. So you were on the spot. Yes, very good.
Okay, there we go. All right. And then like this.
That's good. Yes.
All right, cool. My keyboard decided to start acting up this morning, which is fun.
Yeah.
I need to take it apart again.
And then you need a semicolon.
C++.
Yes, that's right. That's right. Okay. Yep. Okay. That should do.
I think
except that I would.
Sorry.
What was it? Sorry.
I was going to just say I think I added the length to ensure that it wouldn't that it would type error. Take something larger. Yeah.
Right. Okay. Well,
but I don't think that's
yes.
Needed.
That's not. Sorry, my mistake. You should have also taken that thing that you just took out. You should have also done that.
Yeah, but that's fine.
Yeah. Okay. Okay. Do you mind compiling this, please?
I get some warnings. Everything else is good.
Right. Can you also check it? Yes. Yes, I
can. Sorry.
Oh, that was your PDF.
Huh? Oh yeah. No, I have everything in various workspaces.
Well, the interesting thing about the PDF was that it was in the dark mode.
Oh yeah.
I don't know how. I don't know how to do that.
I can show you. It depends on your PDF viewer.
Okay.
And this one runs takeWhile. Let's see. One. I should give takeWhile something, shouldn't I? No, it's fine.
You also need a function, a predicate.
How did you make a lambda in this?
Well, this is how I do it. I put a pair of
curlies?
No, what's that? Square brackets, and then a pair of round brackets, and then a pair of curlies, and then I fill them.
Okay.
Yes. So the first one is the list of things that you want to capture. Now I haven't. No, don't do that. Don't do that.
There's nothing you want to capture from the scope.
You don't want to capture anything in this scope, right? Now the second one is the list of your arguments. Now let's say that you want to check whether something is equal to 3.
Yeah, sure.
No.
That's the argument. Yeah.
No. It's a parameter list. So you would put auto. Have I really never shown this to you?
I think you did, but I don't remember it properly. So
okay, fine. No, you remove that
auto X.
Auto X.
Yes.
Okay.
Okay. Put an auto X.
Okay, there, and then
in the
and then return X is less than 3.
Okay.
Now my apologies that there is no eta reduction. You need a semicolon after the 3.
Yes.
There is no eta reduction, so I can't
Yeah, you can't just put X less than 3. Yeah.
Less than 3.
Just less than 3.
So sad.
I know.
Yeah. Okay.
Make
warnings, but
errors.
No, that's fine.
Errors.
Yeah, you got
no matching function to call return prepend.
Ah, well, you haven't provided the function that you want to, the predicate.
Oh, I didn't. Very good. Didn't I? I didn't. No. Very cool. Very smart.
Yep. Find it.
Did I?
No matching function
One
still.
error. No matching
And-
function to prepend. Ah, right. Your prepend. So prepend takes x as a non-type template parameter.
Fair point. This is exciting. Just fixed it on my own
Aha.
time.
Okay. Inconsistent deduction for auto return. What?
Oh.
So good at finding errors, dude. I'm so good at this.
Right. So one of the right. Okay. Let's go there. Let's go see what's in the
Was that?
code.
Sorry. 120. 120 is this one, and then what does it complain about? List empty and then list 4. Too many initializers for list empty.
Right. Inconsistent deduction for auto return type.
Inconsistent
see what
auto
there is.
reduction.
So let me see your return type. Did I
not have one? I don't think I have one.
Yeah.
They do this?
No.
No. That's not.
Oh, what is going on? You've got square curly braces on line 119 in strange at the beginning.
Yeah,
Is that just your function?
Yeah,
That's fine. That's fine.
Oh, okay, right.
Yeah, happy?
Yeah, it was hard to know.
No worries. No worries, it's cool. Huh. Is it one of these that's complaining?
No.
Let's see. Do you mind putting on line 120?
I was just
Do
reading.
you mind putting an else at the very
Okay.
beginning?
So like
before
here?
before the no, sorry. My apologies. That's also fine, but I would put it at the beginning of line 121.
Oh yeah, sure.
This is just a matter of preference. Okay, now recompile.
Doesn't the else need
Okay.
No.
It's good. It compiles. Just some
Okay,
warnings for our new variables.
I think I know what's going on, but this I'm not sure this is not a bug. Oh, you do still have an error.
No, because the make is there.
Oh, I could clear I could clear if I set it correctly. But no, there. Okay, nothing to be done. Yeah, it makes.
Okay, fine.
Make.
That's yeah.
Right. So I can explain what was going on. So you see, when you have an if else, there is a matter of your compiler knows that it's going to make a choice between one of these two, right? When you don't have an if else, you just have an if without an else. There is no dependency between the two.
Yeah, no.
Right?
So it's not like
now, even though that is the case, I don't think that this should have happened. I have the impression that this is just a bug.
Interesting. Cool.
So
sorry, Jan, can you go? What did you change again to get rid of the bug?
So
Added
on
else.
line
I added else.
121, at the very
Oh, okay.
beginning, yeah,
Yeah, I see that.
at the very beginning of the line, I asked Jan to add an else.
How do I do these?
Right.
Okay, I can do this.
Yeah.
Yeah.
Okay. Let me just see whether I have anything to add to that. Whilst you're doing your thing.
I'm not doing anything.
Oh, you're not? Okay.
I was just writing that there was a neat bug here.
Sure. I mean,
I can stop sharing.
okay,
Or was there anything else that's of interest?
No, you're doing fine. You're doing fine. Now stop.
Stop sharing.
Would you mind stop sharing? Yes.
Yeah.
Okay.
That's cool though.
Yeah, thank you. So yeah, this is my version, which more or less is exactly as yours.
No, you have the else there.
I have the else, yes. I have the else,
Yeah, and
and
you
there
have
is
the
no
logic the other way.
the other way. Yes. Yes,
yeah.
correct, yes. Yes.
You have the
So my
contrast.
the then and the else branch are the opposite way around as yours. That's right. Yeah. Okay. Now, so there's is everyone fine with this solution? Okay. Now, James, would you mind showing us your implementation, please?
Yes. It's
you wanted to show us something fancy.
It's just I decided to do it the other way around. So I wrote span instead, and then just took the first and the second.
Ah, okay.
Because it was going to be, but then there's an interesting implementation of span.
Yeah. Okay.
Not particular. It's just interesting doing the recursive calls.
Right. Okay. Does this compile?
Yeah, and it works. I've got a demo here where I call span. They all have the same. And I get 1, 2, 3, 4, 5, 6 because I split on I is less than 4.
Right.
And
okay.
takeWhile, dropWhile.
Now, go to your implementation, please.
Where? Yep.
Right, guys, I need to teach you something here. On line 127, James, would you mind highlighting that line for us, please?
Yes.
Thank you. On this line, you see an auto on the left-hand side of the equal sign, and then within the square brackets, you see a T and an F. That is the C++ notation for produce a tuple for me and give them the type that you think is right, consisting of T and F, which would then be the result that you get from span, and make pair or make tuple, which means that T will be the first element in that tuple, or the 0th element to be more precise, in that tuple, and F is the first element in that tuple.
Yeah.
Right. So this is when you want to do multiple bindings together.
Sort of pattern matching.
It's a very weak form of that. That's right.
Yeah.
And then so if you want to look at this in the on CPP reference, you need to look up for structured binding, I think, or structured. So let's see. Let me try to find it. Good. Come on. Yes, structured binding declaration. So it has different syntax, pieces of syntax, but it's beautifully done here, as you can see. Now, one thing though.
Yep.
If you ever, and this one is quite funny, if you ever want to include these things in a constant expression, so T and F, then your auto will not do. And the reason is that these are local bindings and you haven't requested them to be const expert. The thing is that you can't do const expert.
Can I not?
Const expert, no, you can't. Const expert auto is not allowed. But what you can do, is pre-const expert. So you can make that const static.
As in, like the
static,
here.
Yes. Oh. Yes. No. Const.
I guess.
Just const. Right. So if you do it this way, then you know that you have then the T and F are available at compile time.
It's broken all of my IntelliSense.
Well, I can imagine why.
I can guess that the better thing to do then would to say just and then span p list.
But yeah, right. You can definitely do that.
And then define them separately.
Right, you can definitely do that. Yeah. I mean, looks like you can't. First of all, you're missing a semicolon at the end, but looks like you can't do that.
It says maybe if I use it, it might.
Wait. It's saying something else. It's saying something else.
It's const void as a type.
I was doing so well.
It just got greedy. Yeah, okay. Let's see.
Maybe if I continue typing, it will type deduct better. That's my thought.
Well, okay. Well, try using. I
was thinking of doing it like this.
Oh, you use to call them T and F.
Yes, T, and then F. Oh, that wasn't the shortcut I was expecting. There we go. Yeah, maybe.
Now it looks like you also have a plus for appending.
Yeah, plus is append for me, so it hasn't worked out.
Okay, I can guess why. That should be because your plus is not const expert.
Let's have a look. It is, but now it's complaining. It hasn't complained before.
It hadn't. Okay.
No, well, I've used it before.
Right.
I have to leave for
right.
work.
Yeah, sure. Let's just take that offline, James.
Yeah.
Right. Okay. I'm sorry that we didn't make it to span, but I would like to ask you guys to do dropWhile and span on yourselves, and we'll take it from the next week. Okay. You guys have a good weekend. I'm going to stop the recording.